right. Thank you for having me. I would like to start with a quick poll, if you don't mind. How many of you use Sidekiq, Rescue, Good Job, SolidQ, Karafka? There's third-party ones, Orcas, Ingest, Temporal. All right, that seems like a lot of you. All right, keep them up. How many of you are aware of how many jobs you process on a given day? And if over 10,000, keep it up. 100,000? Million? If you work for Gusto, put your hand down. 10 million? 100 million? Give me an estimate.
8 billion.
What was that?
8 billion.
Oh, 8 billion a day. You should come up here and do this presentation. How about you? Okay, cool. Let's see, I think that was all way back there. Okay, cool. I look forward to your talk up here one of these days soon. All right. I work for Gusto, which is a payroll company. We do HR stuff, benefits, and more. And we have a fairly large office here in Denver. I want to give you inspiration for this talk real quick. I recently went through a decently sized hiring process and told many people about our infrastructure, our problems, our day-to-day problems. Then I went to RailsConf this year, and we had a booth there. And I told a lot of people about our problems and scaling issues and so on and so on. And there was this universal moment for everybody's face where it just kind of, everyone kind of has this moment along the journey of the description of the problem. They just get a little shocked. And so that is my goal for you today, for me today, for you, is to give you this shock value. Along the way, maybe you learned something, maybe just commiserate with me. But I also want to add a disclaimer. This is not a presentation about Sidekiq, the good parts. I could spend a lot of time on that. I could spend at least 30 minutes on that is, but I don't think it would be as entertaining as what I have for you. All right, my name is Phillip. I live in Atlanta. I've been remote for the last 12 years or so. I'm a senior engineering manager at Gusto, and I lead 2 developer productivity teams. One is focused on Ruby and Rails, infrastructure, tooling, productivity, maintenance, gems, so on and so on. And the other one is on background job processing, which is shock attempt number 1, which is I do get a lot of shock faces of the fact that there is a dedicated team worried about Sidekiq and Karafka. We actually don't own Redis or Kafka itself, which is also a little shocking, but we do collaborate with those teams very often. Another face moment is we are on call 24/7 for it. Remember what industry we are in? A slight blip can mean we miss a banking deadline. That's not great. We have on call, we have a playbook in place that's there to support the people on call. And at one point in time, it was 90% effective. But we automated away a lot of those cases, and that leaves the hard cases behind, which sometimes requires very deep splunking, very creative scenario situations to figure ways out of. Right, because of the type of team we are, it should not be shocking that we try to make it easy to do the right thing and hard to do the wrong thing in general. So we use a lot of danger and Rubocop in order to tell people, are you sure you didn't think about XYZ? Did you know about this case? So on and so on. We have a lot of dashboards so people can see the health of their jobs in production. We have monitors to tell the people when something goes wrong. We try to have points where people can tell something was about to become wrong before they actually become a problem. And then we spend a lot of time in education efforts around documentation, guides, and presentations, and so on and so on. We provide patterns for using Sidekiq within Gusto. It is not uncommon for people to hear about the 3-tier pattern that we use, which is usually a job or a rake task that kicks off a job, which kicks off a batch, which kicks off another series of jobs. This is very common in our case because we use MySQL and Ghost. So we can't just drop a new column on a table and say populate all the UIDs. We have to go row by row and add the UIDs. And so we'll create a job that enqueues maybe 1 million of these. And when that is done, we'll have a batch that's on-call handler that'll fire off the next 1 million, so on and so on until we get through the entire table. A lot of our learnings and patterns we bundle up in a gem, spread it across Gusto for use at all our Sidekiq installations. Next shock attempt is our volume. Not so shocking for some of the people who just learned. I already knew we were not the biggest Sidekiq installation at about 170 million jobs per day. We've gone to 270 without blinking a few times. And I like to say that when a problem happens to 0.0001% of jobs, that's something that happens thousands of times a day. And so we are trying to put effort into fixing those situations. We have a lot of jobs, job classes. We have a lot of periodic jobs. Those are schedules, basically crons. We have about 1,000 workers in production. We're probably not the biggest Sidekiq installation, but maybe it's possible if someone could test. We might be the biggest one on a single instance of Sidekiq, a single Redis cluster, I guess to say. We have a replica, which is there for disaster recovery. We've split out pieces of Sidekiq into different Redis databases so that the operations could be on its own and working even if there's strain elsewhere in the system. Rate limiters, which is the thing that prevents you from doing a specific task too many times in a short period. Those are very Redis CPU intensive, so we tend to put that off in its own Redis data store. Otherwise, it might knock over the thing it's actually trying to protect. All right, this is a question for you all. Our resource constraint. What do you think is our bottleneck for scaling background job processing to, say, double the volume? Is it the CPU of the Redis, the memory of Redis, the CPU available of the worker process, or the memory available to the worker process, or money? It is none of those. It is actually our primary database. If you were to scale Sidekiq to infinity, we would knock down just about every system there is if we enqueued 2 million jobs in like a 5-second span. And the primary database would probably go over first. Next shock attempt, maybe not too shocking, is that we have latency-based queues. We call them SLA queues internally. But the Gusto engineering blog has information over the years about SLA queues. So our blog post, there's a RubyConf 2022 talk about it. And I've heard it referenced at least a couple times during RailsConf this year. Basically, these queues describe the expectation of the job that you put on the queue. So if I put something on the 5-minute queue, I expect it to start processing within 5 minutes. We have a concept called queue shards. These are not Sidekiq shards. They're a little bit about limiting blast radius, but the interface to the job is the same regardless of what shard it ends up, and then we do this thing where we take the class name and distribute it across the shards. It's really just a blast radius thing. This system works really well in setting expectations as well as keeping utilization up. The real-time queue is a little different. All the other queues auto-scale based off of the multiplication of volume over a period of time and their average runtime in a queue. The real-time queue is really a 30-second expectation queue. It is meant for blocking web traffic or things that really affect the user experience. Auto-scaling this queue is very difficult because it is spiky in nature, and auto-scaling usually takes longer than a minute to respond to queue sizes. So we actually scale this queue based off of web traffic over time, which ends up being the parabola of the waking hours of the United States. We protect the real-time queue by only allowing web requests to put stuff on this queue. And we've also learned that we have to prevent retries from going on this queue. I'll go into that in a little while. We have a concept of read-only queues, which is if you put a job on one of these queues, that worker is only able to access a read-only replica of our database. And therefore, we can run these at very high concurrency rates. This is working so well, we're thinking about adding a no database connection queue. And we also have a concept called the replica lag compensator, which I'll go to in just a moment. So we have a custom morgue layer. If you don't know what the morgue is, if you enqueue a job and it processes and it fails, when you've exhausted the number of retries you have configured, it will go into the morgue in Sidekiq. The morgue provides an interface, a web interface for you to go in and put a bunch of check marks and click and retry, delete. A lot of teams rely on the morgue as a way to triage errors as it happen over time. We have monitors in place for teams that look at entries in the morgue and immediately tells the team, hey, it finds the Slack channel, tells them you have X number of things in the morgue. We have Sidekiq options in place where if that happens, a team can opt into being paged when this happens. We have a concept of a morgue manager, which we use to delete jobs in bulk because clicking the check mark 20,000 times isn't fun. We also do a double write pattern where we not only put the dead job into the morgue, we also write it to a database. That database can have a lot more entries than the default or what we have the morgue configured at, which is 100,000. And we have ways to query that data, and then you have the rake tasks to bring it back into queues if necessary. That persistent queue single-handedly reduced our on-call burden quite significantly. All right, we have a concept called kill switching. The idea is to move things between queues. So we have to intercept a job on the way into a queue or when it is coming out of a queue. And then we can place it either in another queue or send it straight to the morgue or just no-op and get rid of it. Because they are implemented as client and server middleware in Sidekiq, which is again the in and the out of the queue, we cannot actually reach into a queue and grab a job out and put it somewhere else. We have to wait for it to actually process before we can actually put it somewhere else, which is interesting. To be clear, there actually is a way to do it, but you have to write Lua in Redis, and I just don't have any confidence in anyone doing that without taking down the production system. All right, we have a concept of an auto rerouter, which is built on top of a kill switch. It is essentially a periodic job that looks at the quantity of a job and the average runtime and determines what percentage of a queue it actually takes up. If it takes more than a certain percentage, somewhere between 5 and 10, we re-enqueue it to another SLA queue that can absorb that kind of impact. When we do this, we Slack the team, we make them aware, and this does a really good job at protecting the noisy neighbor problems and also protects the operations of the SLA queues. This entire thing I just described, it bends. If all this worked without a hiccup, I don't know what I would be doing on a daily basis, but here I am. And so here I am to describe to you just about every incident that has happened related to Sidekiq since I joined the company in rapid fire fashion. All right, very first one, welcome to the company. Retries stopped working. There was a Sidekiq bug and it automatically defaulted all retries to 0. We had to downgrade Sidekiq and re-upgrade it afterwards. Batches, if you don't know what batches are, that's when you take X number of jobs, 100, million, and when they're all done, you have a callback for failure or success, and then you could do something else. Turns out if you have nothing in your batch, we don't fire any callbacks. That was later fixed in Sidekiq. We haven't got to that version yet. But in the meantime, we had to put a no-op job in just about every batch that we found. We had a SLA breach due to a noisy neighbor. I'll say SLA breach a few times here. That's when a 5-minute queue is taking 6 minutes or whatever expectation of the queue isn't being met. I'll go into this in a few as well. We have high primary database load caused by jobs that have slow queries. We were missing Sidekiq telemetry, and that was because we configured the Sidekiq leader wrong slightly. If you don't, I will reference the Sidekiq leader again in the future, which is all your processes in Sidekiq elect a leader, and you can run a thread or some logic on the leader, and then you know that only happens one time across your entire fleet. Again, I will reference that later. We had Redis memory issues because payloads were large. Our morgue overflowed past the configured 100,000. A simple job bug, when a job it has millions and millions in queued, can just wipe the morgue in just a couple seconds. You had no chance of responding in the first place. It happens again. A slow job caused by high database load. We have skipped periodic jobs. We think the leader had a little issue with it being CPU bound, so we threw some CPU at it. High database load caused by, so we have a mechanism that pauses all slow queues greater than 1 hour whenever our primary database senses that it has high load. And we do that to buy incident responders some time. This finally happened. This was one of the first times that mechanism actually engaged. But it wouldn't actually pause the queue. It tried and we couldn't really figure it out. So very quickly, we just rerouted a bunch of jobs to a queue that had no workers on it, and that effectively paused things until we got things working again. Doing more research, pausing in Sidekiq was broken all across the board. Mike fixed it in Sidekiq, and we upgraded, and we're fine. More overflowed again. A queue almost breached an SLA. We rerouted the job, but the kill switch itself, which usually takes about 30 milliseconds to process, was taking quite a few seconds. And so an entire queue backed up. Again, we were CPU bound, threw some more CPU at it, and then we added some monitoring and moved on. So I mentioned this concept of a kill switch, which is custom code at Gusto. That interacted funny with batches. So you have a batch of 1 million jobs, you kill switch one out, and that is actually a failure scenario, but we removed it from the batch, and so we were firing the success callbacks of the batch, which was not expected whatsoever. That was an interesting mix of Sidekiq behavior and our code, and then it turned out people were relying on that other behavior, which is referenced in the last talk as well. But that was an interesting situation as well. High database load, the queues auto-paused again. We had an issue with a Sidekiq upgrade where we lost an entire morgue. So we have 2 really large code bases at Gusto. We upgraded the big one just fine. Upgraded the second one, morgue disappeared because the second one was using Redis namespaces, which we didn't notice because the main repository did not have Redis namespaces. So a version upgrade in Sidekiq removed namespace support, and well, a lot of things suddenly disappeared. So we dropped down into Redis, dumped all the keys into a Google Sheet, and everyone had a manual morgue essentially. A Redis memory issue, largely due to a large job payload. Someone did a mass manual retry on the real-time queue, which I said was 30 seconds essentially, right? It was in the millions, and it caused a real-time queue breach. Later on, we figured out, okay, retries don't belong in the real-time queue. We redirect them somewhere else. Noisy neighbor due to slow query. Another noisy neighbor. The auto rerouter didn't catch it this time because the job was new, and the auto rerouter kind of waits for 24 hours worth of data before it makes decisions. But we needed to act really quickly for this scenario. We had another high Redis memory issue due to large payloads. We have a process running on the leader that kills jobs after a certain amount of time. It's configurable based off of which queue it is, from 5 minutes to 35 minutes. And for some reason, it wasn't working, and so some of our workers got hung up, and then we had SLA queue breaches everywhere. Periodic jobs were not firing. Actually, just kidding, we had Datadog telemetry problem. That was scary. All right, we're moving on. We had another SLA breach due to a noisy neighbor. Someone fired off a rake task touching every row in a multi-million, 100 million plus database table, and it had callbacks everywhere. They had other callbacks, and just the Slack message job fell over. We had another SLA breach. In this scenario, as I mentioned earlier, we have a replica of our database. It is possible to write to the primary database from, say, a web request, enqueue a job that fires off on a read-only queue, and for that read-only queue to read from the replica database, and all that happened faster than the actual database replication. And so we were reading stale data. So you could be reading stale data. So we have a mechanism that causes a sleep of at least 10 seconds, because it never happens more than a second. So we make sure that the job is enqueued or ran at least 10 seconds after the actual enqueuing. But there was a JSON gem upgrade, and it did something weird with the date, and it added EA plus 18 over there and caused our calculation for sleep time to go to infinity. And so we just slept and slept. Downgrade JSON, upgrade it later, we were fine. All right, we had a bunch of periodic jobs that did not fire. A periodic job is basically a cron job. I want this thing to happen every day at X time. That periodic job gets enqueued by the leader. And if there's no Sidekiq leader, that job will not get enqueued. So we had a situation where the Sidekiq leader was down for 8 milliseconds before another leader came up, and that wrapped a minute change that had dozens of jobs enqueued at that moment, and so none of them ran. I'll tell you a little bit about that situation, how we got past that later. Another morgue overflow. Another morgue overflow, but this was due to a job being renamed. Same situation, really. Someone accidentally hit the delete all button in the morgue. They also did not like this, so they patched out the delete all button in the morgue. We had an SLA breach. We accidentally broke the metrics one day with a refactor. Okay, it happens. But our autoscaler depended upon that data. And so none of our queues were scaled anywhere beyond the minimum. And so SLA breaches everywhere. That same situation made some of our jobs that took a lot of memory stay in the queue a lot longer than normal. So our Redis memory shot up. After that, we introduced payload metrics. I'll go into that a little later as well. Redis CPU spiked every day at the same time. And that was because there was a periodic job that fired a high volume of other jobs. We have a global rate limiter that looks at job class and says, okay, you can't enqueue more than 2 million jobs in a very short period of time. It does that by sampling 1% of the jobs that go across and sends it to a rate limiter. That rate limiter, they can extrapolate based off 1%, multiply by 100, and you know what the volume is. And the problem is that mechanism only stopped 1% of the jobs above the threshold. So we'll sample 1%, stopped 1% above 2 million. And so there were many teams that were going across this barrier and had no idea. So we started a progress of adding monitors so every team knows when they're approaching that boundary. Someone ran a rake task, and it caused every row in a table to fire a job that hardly ever ran, but now it is, and so suddenly that queue got completely backed up. A job was renamed, that's fine, but it had millions and millions enqueued, and an uninitialized constant error was happening deep in Sidekiq before middleware even has a chance to run. So we couldn't kill switch it because the exception ran before our kill switch process was able to move it to another queue, and we couldn't do anything about it other than just drain the queue, and they just kept re-enqueuing and re-enqueuing. A notification wasn't making it to users fast enough. A job on the 5-minute queue was taking 20 times longer than normal, which just happens. Incident, people respond, and eventually the situation was fixed. But now all these jobs that have 5-minute expectation are on the 12-hour queue, and it had 10 hours of jobs on it. And so there was no way to go into the queue and grab those and reprocess them. So we just had to drain the entire 12-hour queue. I'm gonna go into this a little bit more later. We had another SLA breach to a noisy neighbor. This time this was a rate limiter that had never been really exercised before. So a job that normally took a couple seconds was taking minutes and minutes because of a rate limiter. Our auto rerouter uses 3 days of data in order to blend what has been happening. And so this happened too quickly for us, the auto rerouter to respond. And finally, we made some data log changes, and now metrics are double tagged both on the job where it was enqueued and where it was processed, and now we have monitors going off everywhere because of it. So that was a false alarm, but it did cause a little panic. All right. All right, so we make improvements to that. We don't just let it happen, right? Or as someone on the team loves to say, all problems can be solved with enough code. And so we have a lot of it. So clearly, we try to reduce the incident probability of happening. We try to understand when incidents are about to happen so we can detect them quickly. And we try to get the right people in the room. We have a lot of code that finds the right team, their Slack channel, associates who is on call at the time, brings them in the channel as soon as we can. And then we spend a lot of effort trying to reduce the time of once we are all gathered together, how do we cut that time from minutes down to seconds if we can? Latency queues in general get a workout. There's a lot of material out there about how great latency queues are, and they are, but I figured I would spend a little bit about how they get bent a little bit, which is there is one trifecta that hurts really badly, which is sudden high volume, high compute time, and the job itself is sensitive to latency. That trifecta is happening a lot in the AI era, and autoscaling can't react fast enough, and they are noisy neighbors. High volume once a year tasks put pressure on latency queues. There's a lot of them. Remember what industry we're in? A lot of things happen once a year, and suddenly out of nowhere, SLA breaches everywhere. And then there is this multi-stage choreography of batches that touch models, that cause other callbacks, so on and so on. Every step of this re-enqueuing process adds variability into the end-to-end time, and just a little, like within normal period of expectation on an SLA queue can cause massive changes and variance across the board. Batch callbacks by default go to the queue that the last job was processed on, so many teams just pin it to the 5-minute queue, move on. The auto rerouter can move jobs between queues, and I think I said this earlier, sometimes jobs get to another queue and it's hard to pull them out, but sometimes jobs get pushed to a slower expectation queue and people realize there's not many neighbors here and things are going faster. Why don't we just leave it there for a little while? There's also this tendency to use SLA queues as the expression of what is tolerable for the end user experience. It makes sense. User can absorb 5 minutes experience, put in a 5-minute queue. But then we have a tendency to rely on that for the entire monitoring of the system, using the SLA queue as an indicator of health, using the auto rerouter as the moment of action, when really we should be thinking a little bit sooner. So that auto rerouter, a lot of times it becomes the action point and no one likes seeing it at their front door when it tells them that something has moved. Mind the gap, I touched this a little bit earlier. This might be unique to Redis. Love to hear if it isn't. Imagine you have a circus and you're trying to figure out how many people are at the circus or many things are at the circus. Use turnstiles to measure in, use turnstiles to measure out. You take the difference, that's what's at the circus, right? And at the end of the night, you can zero it out, but we cannot zero that out. And we have no idea the size and shape of things at the circus. Again, we could reach into Redis with a Lua script. My understanding is that can just freeze the entire system, so we don't do that. We might be able to do it on a replica, that's another story. But the act of measuring problems, what is in there during a problem state can cause the problem. All right, I think I mentioned this a little bit. The auto rerouter is unfriendly. There's a lot of great things about the auto rerouter. It solves an operational issue, but job creating teams do not like this. It comes with urgency out of nowhere. It needs an early warning system. No one likes to wake up and see their job is moved to another queue because now their day starts that way. Or they end up just leaving the kill switch the auto rerouter has created there for a while. It can send jobs to way, way too slow of a queue for the business to be able to tolerate. And again, they get stuck in there until a server is actually able to process the job. We are thinking about either supplementing or reworking this entire system. I've mentioned this a little bit earlier. There might be urgent situations where the primary database is coming close to falling over. So we pause a lot of slower queues in order to buy time for incident response. And then we found out maybe sometimes people leave queues pause for too long. Maybe we need to be aware of that as well. We don't actually use this thing very much now because of a lot of great effort into actually ensuring database health. So this hasn't engaged in quite some time. All right, earlier I said our constraint's actually a primary database. Let's say we remove that constraint. The next constraint is actually the CPU of Redis itself. Redis is single-threaded. Therefore, all of Gusto runs on a single thread. And we can no longer throw money at this because we are at the highest clock speed of Redis, that Redis AWS provides for Redis. So adding more money just adds more threads or cores, and that does not help us right now. We have a mechanism, I said earlier, that tries to prevent the most common Redis CPU issue we have, which is millions of jobs in a very short period of time. But sometimes things still get around it. We have decent telemetry on how much memory Redis as a whole is using, and that's built in through AWS, goes through CloudWatch, and we can find it in Datadog. Eventually, someone wrote an AWS Lambda that actually goes and asks Redis, what is the memory size of each key in Redis? And each key kind of some of the keys map to queues, and then you dump it to CloudWatch and mix it Datadog. That wasn't enough, and so now we were trying to find more data on actual job payload size, so the arguments of the job. In our history, there have been times where we've accidentally, or maybe someone intentionally dropped some very large payloads into Redis, measured in megabytes, 3 digits. All right, we have custom leaders on the thread, custom threads on the leader. I talked a little bit about that, the leader a little earlier. We have a thread we call the watchdog, which looks at all across our workers and finds jobs that have been running for more than 30 minutes. This is a periodic job, and it will send Sidekiq a signal to turn that job or shut that thread down. The watchdog worked really well until we realized jobs were going 30 minutes, getting shut down, and then Sidekiq superfetch would just grab it and put it back in the queue, and then it would get executed and take 30 minutes, just over and over and over again. And we realized, okay, maybe we need to add some custom code to actually increment the retry count as well during it. We also have some aggregated Datadog metrics that we do in the leader. We try to fix periodic jobs. Missed periodic jobs usually happen when there's an unhealthy leader. So when a leader shuts down and there hasn't been a new one elected yet, we are aware that we're supposed to make periodic jobs idempotent and run many, many, many times. We have a lot of code over a long time, and it's kind of hard to ensure this is true all the time. So yes, we have a periodic job that looks for missed periodic jobs over a recent period and then queues those periodic jobs periodically. This has added lots of nines to our reliability equation for now and has done enough for the time being. We have an observability layer on top. We send a lot of stuff to Datadog. We also send poison pill information. We send superfetch information to Datadog. But tracing is still rough. When you have a rake task, it fires a job, it fires a batch, it fires an active record callback that has a batch, so on and so on. It's really hard to find where you started and where you ended. We also tag jobs so the Sidekiq UI is easily filterable. We have a custom layer on top. Not too interesting, to be honest. We have a manual job concept where you can queue any job as long as you have yourself and someone else approve that job. We have an audit log of the pausing and unpausing because it's kind of nice to know who did what, when, so we can know why they potentially did it. We have the kill switch page as a UI for the feature I talked about earlier. In our periodic job page, we have a header that lists all the recently missed jobs. The morgue manager of UI for that concept that we talked about earlier. This job info page we built this year and has cut down our incident response time for certain actions from minutes to seconds, and that it allows us to search for a specific job and immediately tells me where's the source code, what team owns it, what's their Slack handle, what's their on-call pager handle, service name, all that, and that has been amazing for really critical times. It takes many teams to pull all this off. Redis expertise, different team than ours. Evaluating Valkey versus Dragonfly, different team than ours. Compute expertise. How do you auto-scale based off of queue projection with a Kubernetes, doing all these things? How do you auto-scale based off of network traffic? I have no idea. And then there is this thought that product engineers experience our offering differently than we intend, and they actually have very interesting insights into our system that are just completely mismatch what we thought we were actually providing. Schedule jobs. I was at RailsConf this year, and I was sitting on the side of the wall, and Andrew Markle from Fullscript was giving a talk migrating their background jobs to SolidQ, and he mentioned they had a problem with scheduled jobs being scheduled 100 years in advance. So within the hour, I went back to my hotel room, and I pulled up Sidekiq UI, and I was like, oh, here we go. And okay, we don't have that problem. So it was shocking to me, maybe not to y'all, but I was like, oh, okay. But we added a task to prevent that situation in the future anyway. All right, side effects. Any system can be stressed by mutating state. This applies to database queries, API calls, Ruby code, whatever layer you can think of. And you should really question if you need to mutate state and cause action. And maybe avoid doing it all at the exact same time every day. Maybe read between the lines here, but I like to call it the latency-sensitive massive parallel distributed clock. All right, moving on. This is not shocking to us. We know how to scale Sidekiq into the future. Shards solve almost all the problems of scaling into the future. We just have some code that we need to rework. We're heading in that direction. This problem space is awesome. It really does it for me in the sense that at my fingertips is the power of an entire business running through a single Redis thread that we have to keep healthy. The debugging, the splunking, the metrics gathering, interpreting dashboards, timestamps correlation, flame graphs, database query logs. Knowing every part of our infrastructure stack is necessary for this. Collaborating with many product teams, many infrastructure teams just to scale, alleviate pain, create happiness and the experience of it, so on. This is awesome. We will be using Sidekiq for a long time, I am sure. Mike Perham has created a product that has withstood the test of time. Again, this was not a presentation on the good parts of Sidekiq. This was a shock value presentation. We know how to scale it into the future. Maybe a few of the things I described are Sidekiq specific. Quite a bit of it's Redis specific. Some of it might actually be Ruby specific, but the rest probably applies to any tech stack out there. I want to say thank you to my predecessors, my teammates, the people I work with every day. I did not come up with a lot of this myself. This is building on top layers of understanding over time. Not shocking, we're hiring, Gusto's hiring all over the org, many different types of roles, including I might be hiring for this team very soon and my other team as well. So keep an eye on our job board, LinkedIn, so on and so on. This specific problems I show here will be part of at least one of these roles. And most importantly, thank you to my wonderful family for supporting me. And I would love to talk to you in that hallway track about any of the things I hear that resonate with you. Thank you.